So we are going to continue, and I'm going to finish the lesson 1 in your Math iReady instruction. We're going to do right now page number 5, 6, 7, and we are going to continue what we had in class. They're asking me to connect it. Now you will explore the concept from the previous page further. So that one is from the page we did before. It says simplify 3 to the second power to the fourth power. Remember that we are solving a power of a power, okay, or products of powers. So in this case, remember the formula. We are going to have a formula now that says that if you have n to the a to the b power is equals to the same base, n, and then we multiply the power. So you are going to have a times b, where n is different than 0, and we are going to do it at the end. So in this case, simplify. So you have 2 times 4 equals 8. So you have 3 to the 8th power. Okay? Then we're going to describe the relationship between the exponents of 3 to the second power to the fourth power and the exponents of 3 to the 8th. And it's pretty obvious here that we multiply the two exponents. So in this case, you can write that the two exponents were multiplied. They were multiplied together. Or you just write 2 times 4 equals to 8. Okay, let's move to number 4. In this case, number 4, I have complete the examples of products of powers that have the same base and the same exponent. So in this case, you have 5 to the 8 to the 6th power is equals to 5 multiplied how many times? You can count, okay? 1, 2, 3, 4, 5, 6, 6 times. So that's the reason why we have 5 is the same base. Remember that what they are using here is n to the a times n to the b equals to same base, and we add the exponents a plus b. Well, this is a plus b. So I have 8 plus 8 plus 8 plus 8 plus 8 plus 8, which is 6 times, or we just multiply 5, and then 8 times 6 in this case is 48. Okay? That's the simplified process. Then we have exactly the same, 953 to the 7th power to the 3rd power equals to 953 multiply 1, 2, 3 times. That means we're going to add the exponent 7 3 times equals to 953, 7 times 3. And we know that 7 times 3 is 21. So the base is the same, 953 to the 21st power, 21 power. Okay, so in general, now we have the formula. In general, for a product of powers that have the same base and the same exponent, na to the b, then we're going to have n a times b. That will be the general form where n is different than 0. N cannot be 0. So now let's look at the following examples. Let's simplify the product of powers when the bases are different. Now the bases are different and the exponents are the same. So in this case, I have 2 to the 3rd power, 4 to the 3rd power. Then number 6, they ask, write an expression without exponents that is equivalent to 2 to the 3 power, 4 to the 3 power. So in this case, I'm going to have 2 times 2 times 2 times 4 times 4 times 4. So I have 2 to the 3rd power, 4 to the 3rd power. Now, what we're going to do, apply the associative and commutative properties of multiplication to write your expression as the product group of 2 times 4. So how many? And what we need to do. So you have 2 times 4, 2 times 4, and then I have 2 times 4. So in this case, let's form the groups. So I have 2 times 4, then 2 times 4, then 2 times 4. So look at the question that they have in number 8. How many groups of 2 times 4 do you multiply together to get this value? How many times? 1, 2, 3 times. So you have 3 groups. 3 groups, okay? That's what we got. Now next, complete this the equation. So we're going to complete the equation in this case. So I have 2 to the third power, 4 to the third power. So you have 2 times 4 to the, where is the exponent? It's 3, so to the third power. Then we multiply. What is 2 times 4? Is 8. So what is the general form? Remember, we are looking for the formula. What is the general form? In a general, for a product of powers that have different bases and the same exponent, so we have the same exponent. A to the n, b to the n is equals to, in this case is a times b, so a times b to the n power, where a is different than 0 and b is different than 0. So neither of these two numbers can be 0. They have to be different than 0. Okay, now try it. It's an example for you. Use what you just learned to solve these problems. Write your answer using exponents. Show your work in a separate piece of paper. So if you have a separate piece of paper, you can do it. So you have simplified 2 to the 18th power to the 8th power. So where is that one? In this case, it's going to be 2, 18 times 8. I know they want the answer in that space, but I'm going to take one extra step. So this is equals to 2. 18 times 8 is equals to 144. Then simplify. Now look that the bases are different and the exponents are the same. So the form is 4 times 25 to the 9th power, and 4 times 25 is equals to 100 to the 9th power. Okay? So that's the solution. Multiply the bases. 4 times 25 equals to 100 to the 9th power. Okay, let's move to the next page. So I have page 6. So what I have, 0 and negative exponents. So now, read the problem below, then explore simplify an expression with exponents equals to 0. So they're asking me to simplify 5 to the 0 power. Let's model it first. We're going to try to figure out what's going on with that 0. So it doesn't make sense to ask yourself, what is 0 5 times multiplied together? Okay? Because so far what we've been using is exponents greater than 0. For example, 1, 2, 3, 4, 5. So if I write here is 5 to the 1, 5 to the 2nd power, 5 to the 3rd, 5 to the 4th, and so on. Those exponents are the ones that we've been using. Now, so far, you have word powers where the exponents are counting numbers. 1, 2, 3, 4, 5. It's what I just mentioned here. You have seen that when you multiply powers with bases that are the same, you add the exponent. So, for example, if you have 5 to the 0 times 5 to the 4, bases are the same, so base is the same, and you add the exponent. So 0 plus 4 equals to 5 to the 4th power. Here's the formula. That's the formula that I just used. Now, knowing this information, look from this one. So you multiply 5 to the 0 times 5 to the 4, and you still get 5 to the 4. So what happened? Okay, let's solve the following example, and we are going to try to explain it. You know that 1 times any expression is equivalent to that expression by the identity property of multiplication. I mentioned that in class. For example, if you have 5 times 1 equals 5. 2 times 1 equals 2. Negative 2 times 1 equals negative 2. 7 times 1 equals 7. So that's the identity property. Whatever number you multiply times 1, you get the same number. Okay, so it's called identity property of multiplication. So in this case, you multiply 1 times 5 to the 4th power is equals to 5 to the 4th power. Now look at this one. 1 times 5 to the 4th power equals to 5 to the 4. And then look at this red. 5 to the 0 and 1, and you still get the same solution. 5 to the 0 times 5 to the 4 equals to 5 to the 4. We mention it here, okay? So 5 to the 0 must therefore be equals to 1. So 5 to the 0 is equals to 1. Now let's move to the next one and see what's going on, okay? So let's connect it. So if we simplify 5 to the 0, is equals to 1. That's what we just did. Complete the examples. For example, 12 to the 0 equals to 1. So if you have a value equals to 1, I'm going to use this one. So then you have that 12 to the 0 is equals to 1. But I'm going to expand. For example, 5 to the 0 equals to 1. 12 to the 0 equals to 1. 7 to the 0 equals to 1. 2 to the 0 equals to 1. Negative 1 to the 0 equals to 1. So whatever number to the 0 power is going to be equals to 1 except 0. And that one we're going to explain it later. So you have here negative 7 to the 0 power is equals to 1. So in a general form, or a formula if you want to call it that way, in a general form, for a power where the exponent is equals to 0, n to the 0 is equals to 1, where n is different than 0. So n cannot be 0, okay? N cannot be 0. So let's move to 16. The rules of product of powers also apply when the exponent is a negative integer. So in this case, complete this equation. 6 to the 5 times 6 to the negative 5 is equals to 6 to the 0 power. And I'm going to explain in a minute. Then 6 to the 0, according to these properties, 6 to the 0 is equals to 1. Now, let me explain. If I have 6 to the 5 times 6 to the negative 5, and then we said that is 6 to the 0, what's happening? Remember the formula, n to the a times n to the b equals to n a plus b. The bases are the same and we add the exponents. So in this case, the bases are the same, so we have the same base, and we add the exponent. So we have 5 plus negative 5. Let me do one extra step. 6, 5. Positive and negative is negative 5 equals to, base is the same, 5 minus 5 is 0. It's exactly what you got here. So in this case, we're going to have 6 to the 0 equals to 1. That's the way we reach to that solution. Now, we also mentioned in the class, now complete this equation. 6 to the 5 times 1 over 6 to the 5th power is equals to, then we have some spaces. We already know that a number times a reciprocal equals to 1. For example, and I'm going to use this piece of paper here. For example, 3 times 1/3 is equals to 3 over 3 equals to 1. I'm going to, every time you have a number, a natural number, for example, I'm going to say 7. It got a denominator that we don't write, and that one is 1. Okay? So for example, you have 2, 3, 4, 5, 6, 7. You can make those ones a fraction, and the denominator is going to be always 1. Okay? So in this case, you have 3 times 1/3. What is the denominator? 1. So 3 times 1 equals to 3. 1 times 3 equals to 3. So you have 3 over 3. If you divide, 3 divided by 3 equals to 1. That's the reciprocal. Now, where is the reciprocal of 2? Okay? Is here. Where is the reciprocal of 2? Is 1/2. What is the reciprocal of 7? Is 1 over 7. Why? Because the denominator is 1, and what we do is just flip those numbers. That will be the reciprocal. You flip it. So you have 7 over 1. So the reciprocal is 1 over 7. You have 2 over 1. Where is the reciprocal? 1 over 2. If you have 3 over 2, where is the reciprocal? You flip it. 2 over 3. See? You just flip it. So in this case, what is the next example? Now complete the following. Now complete the following. You have 6 over 5 times 1 over 6 to the 5. So again, 6 to the 5 times 1 is 6 to the 5. And then over 6 to the 5. And if you divide, these two are the same numbers. If you divide these two, it's equals to 1. So it's going to be equals to 1. That will be the solution. Now, is there any other explanation? Let me try here. So you have 6 to the 5th power times 1 over 6 to the 5th power. Okay? Remember that this 6 to the 5th got a denominator 1. So 6 to the 5th times 1 is equals to 6 to the 5th power over 1 times 6 to the 5th equals to 6 to the 5th power. So you have exactly the same. If you want to use the properties of exponents, you remember that if you have n to the a, n to the b, if the bases are the same in a division, then you have that n a minus b. So we apply the same. Where is the base? 6. Exponent 5 minus 5. And this is equals to 5 minus 5, 0. 6 to the 0. Where is 6 to the 0? 1. Exactly the same solution. Exactly the same solution. So it's up to you to choose the step. Now let's look at number 18. And I'm going to write it here. Since, look at this one, 6 to the 5 times 6 to the negative 5 is equal, in this case, we said 1, okay, it's equals to 1. And 6 to the 5 times 1 over 6 to the 5 is equals to also 1. Then 6 to the negative 5 is equals to 1 over 6 to the 5. And I'm going to explain it in a different way. For example, so you have 6 to the 5 times 6 to the negative 5 is equals to 1. And then we have that 6 to the 5 times 1 over 6 to the 5 equals to 1. Then we said that 6 to the negative 5 is equals to 1 over 6 to the 5. So look at this one. If you erase these ones, see these two are the same, 6 to the 5, 6 to the 5, I just cross them out. 1 and 1, they are the same, so I'm just, what do you have? 6 to the 5 is equal to 1 over 6 to the 5. So this one is true. So that one is true. So now, if we complete the examples, number 19, in this case, 10 to the negative 6 is equals to 1 over 10 to the 6. Then we have negative 34 to the negative 7 is equals to 1 over negative 34 to the 7. And then we have the last one, 1 over 142 to the 13. That means in the left side, you have 142 to the negative 13 power. So we discover a general form. So in general, for a power where the exponent is a negative integer, n to the negative a, then your general form is 1 over n to the a, where n is different than 0. So in a few words, you cannot have negative exponents. For example, if you have 1 is equals to 7, if you want to write 1, fine, okay? 8 to the negative 2 is equals to 1 over 8 to the second power. See, if you have a negative exponent, that number goes to the denominator with the exponent positive. So you have, let me say, 15 to the negative 7 is equals to 1 over 15 to the 7th power. 1 goes in the numerator, and then the base and the exponent goes in the denominator with positive exponent. Okay? One last one. Negative 21 to the negative 3rd power is equals to 1 over negative 21 to the 3rd power. So, we cannot have negative exponents. We move them to the denominator, and numerator is going to be 1. Let's give it a try to the following ones. Use what we just learned to solve these problems. Write your answer using positive exponents where appropriate. When appropriate, show your work and separate piece of paper. So simplify. 455 to the 0 power. We have the property here. If you have to the 0 power, is equals to 1. So all this one is 1. And then they're asking you to simplify. 19 to the negative 4, you have a negative exponent. So you have 1 over 19 to the 4th power. And that's the solution. Okay. So in this case, we're going to use the properties of exponents to solve page number 8. And we have using properties of integer exponents. Study the examples below, then solve the problems 23 and 25. So what we have, simplify 2 to the 4 times 2 to the negative 7. So what we did here, write the problem. The product of powers with equivalent bases. This problem you have to apply more than one rule of working with exponents. So we're going to use more than one. We're going to, in the classroom, we'll be pairing and sharing. We will do a grouping technique. If x and a are counting numbers, and x to the negative a less than or greater than 1, you need to explain. So in this case, for example, the bases are the same, so we add the exponent, 4 plus negative 7. Then 4 plus negative 7 is equals to negative 3, so 2 to the negative 3. And remember, we cannot have negative exponents, so that 2 goes to the denominator with positive exponent. So in this case, we use the reciprocal with positive exponents. Solution, 2 to the 4 times 2 to the negative 7 is equals to 1 over 2 to the 3rd power. Let me try it here. So you have 2 to the 4 times 2 to the negative 7 is equals to, bases are the same, then we add the exponents, 4 plus negative 7, okay? So this is equals to 2, 4 plus negative 7 is equals to negative 3. We cannot have negative exponents, so we write 1 over, base is 2 to the 3rd power. And that's my solution. That's what we did. So number 23, let's take a look at that problem, okay? And then we're going to show work. Remember that the order of operations, simplify the expression within the parentheses first. So what we are going to do, look at this one. I'm going to write the problem. So I have 3 to the 2nd power times 4 to the 2nd power to the 5th power. According to the rules of the order of operations, parentheses, what is inside the parentheses goes first. So I have 3 to the 2nd power times 4 to the 2nd power. Bases are different, but exponents are the same. So I have the formula. A to the n times b to the n is equals to a times b to the n. So this is equals to 3 times 4, I'm going to do double parentheses, to the 2nd power to the 5th power. What is 3 times 4? It's 12. So 12 to the 2nd power to the 5th power. What we have now is a power of a power. So you have n to the a to the b power is equals to n a times b. Okay, always remember that in this case n has to be different than 0, and it is. So I have 12, 2 times 5. So my solution will be 12 to 2 times 5 is 10. So what is my solution for the problem? So 3 to the 2nd power times 4 to the 2nd power to the 5th power is equals to 12 to the 10th power. Okay? So move to page number 9. They're asking me to simplify the following problem. Okay? Simplify 9 to the negative 8th times 1 over 9 to the 3rd power. Write your answer with positive exponent. Okay? Write your answer with positive exponent. So what I'm going to do, I'm going to work in a reverse here. Remember what you know about adding negative numbers. So I have 9 to the negative 8, okay, times 1 to 9 to the 3rd power. I'm going to move this 9 to the numerator, okay, I'm going to move it to the numerator, and I'm going to explain why. So I have 9 to the negative 8 times 9 to the negative 3. If I move this 9 upstairs, then the exponent moves to negative. So why I did it? Because I want the same base so I can add the exponents. So in this case, I have 9 is the same base, negative 8 plus negative 3. It's the addition of two negative numbers. It's something that you've been working with. So in this case, I have 9. Negative 8 plus negative 3 is equals to negative 11. Now I need to go back and says I cannot have negative numbers. So if I have n to the negative 8 is equals to 1 over n to the 8. I cannot have negative numbers in the numerator. So in the exponents. So this is equals to 1 over 9 to the 11th power. So what is the solution? So you have 9 to the negative 8 times 1 over 9 to the 3rd power equals to 1 over 9 to the 11th power. Next one is a multiple choice, so we're going to choose the answer. If I have, which expression is equivalent to negative 45 to the negative 3 over 45 to the 3rd power? So which expression is equivalent to that one? It's up to you. Remember that you have a division here. So far what we have, remember if you have n to the a, n to the b equals to n a minus b. I'm going to do it that way and then I'm going to explain it. So bases are the same. So you have 45 negative 3 minus 3 is the subtraction. In this case, we're going to add these two negative numbers. So I have negative 3 minus 3 is equals to 45 to the negative 6th power. Remember, we cannot have negative exponents. So in this case, I have 1 over 45 to the 6th power. So which one? A, B, C, or D? In this case, the right answer is C. Isaac chose A as the correct answer. How did he get that answer? Okay? In this case, I'm going to say if he chose A, he divided these two numbers. Negative 3 divided by 3 is equals to negative 1. So in this case, you can write here, he divided the expression. He divided the expression instead of subtracting them. The exponents. Instead of subtracting them. Okay? So in this case, let's think a little bit, and you can do it at home. Talk about the problem and then write your answer together. So think about those problems and then you write the answer. And if you have any question, you can email me, or you can post it in the comments in your Google Classroom, and I will see you later.